Section 8.2 is about parabolas. If you have a double cone, like you see in the picture here, and you slice it a different way, you create something called a conic section. And there are 4 conic sections. You can slice it and get a parabola, a circle, an ellipse, or a hyperbola. We're going to spend the rest of the chapter looking at these 4 conic sections, but the one that we're going to look at in this video specifically is a parabola. Here you see the general form for the equation of a parabola when you have the vertex at spot HK and you have an axis of symmetry at x equals h. Now it's also useful to note that if the a value is greater than 0, you get a parabola that opens up. Likewise, if the a value is smaller than 0, you get a parabola that opens down. Now there's more to parabolas than just what we see here. If you look on this slide, we'll learn about a couple different definitions and words that we can use to describe parts of a parabola. A parabola can also be defined as a set of points that are the same distance from a given point called a focus and a given line called the directrix. In this parabola, you see the focus is right here. It's a point that's somewhere inside of the parabola, and the directrix is this dotted line you see at the bottom. Now a parabola is all of the points that are the same distance from that point and this line. It's the same distance. Another definition is this thing called a latus rectum. That is the line that goes through the focus and is perpendicular to the axis of symmetry. So you see that line right here. There's all these different characteristics that help us describe what a parabola looks like. And if you look at this concept summary, you'll see it's all summarized for you right here. This column are the parabolas that open up and down. Look like this, or they might even open down. This column are all the parabolas that open left and right. Perhaps something that looks like this. And you can find out a ton of information if you just pause the video and look at this concept summary. In this example, we have a quadratic equation, and we want to write it in standard form. And then we want to use that standard form to find the vertex, the axis of symmetry, and the directions the parabola opens. Since this is a y equals, here's what the standard form looks like. So if I can get my equation to look like this form, I can easily find the h, the k, and the a, which are the actual 3 things that I'm looking for in the problem. So we're going to start by taking these first 2 terms, and I can take a 3 out of them and make this an x squared plus 8x. Now I'm going to leave some space in there, and you'll see why in a minute. And then I'm going to leave the 50 alone at the end. Now the reason I left some space in here is because to write this in standard form, I need a binomial that's squared. To do that, I have to create a perfect square trinomial. And to do that, I have to do something called completing the square. You try to create the perfect C here that will make this a perfect square trinomial. And the way that you do that is you take this b and you cut it in half. You get a 4 and then you square it. So if I do that, I get a 16. And now I'm going to add the 16 in here. Now because this is an equation, I can't just add 16. If I add 16, I'll be changing the problem, and I can't do that. So if I add 16, I also have to subtract 16 so that I'm actually adding nothing. So I'm going to do this in a clever way. I'm going to subtract 16 back here, but you also have to be careful because I'm not really subtracting 16. Because this 16 is in parentheses, and that's being multiplied by 3, I'm really adding a 3 times 16. So I need to subtract a 3 times 16. So in a sense, I've not changed this problem at all. I've added 0. I've just added 0 in a special way that I created a perfect square trinomial in here. And let's see what that does for us. So now I know that this is going to be something squared. And it's going to be an x plus 4, because that's what I set it up to be when I made my perfect square trinomial. Now over here, 3 times 16 is 48, and then 50 minus 48 is plus 2. So now this is pretty good in terms of my standard form. In fact, I like the way that looks. I think that's exactly what I want it to look like. I do have to be careful that this plus 4 is really an x minus negative 4. And that's going to be important later when we look for the h and the k. So now you should be able to look at this and say my h is -4, my k is a 2, and my a is the value in front of the parentheses, my a is a 3. And if you go back to the concept summary, you'll see that the vertex is at the point hk, so my vertex is at -4, 2. Now the axis of symmetry is the line x equals h, and in this case my h is -4. And because my a value is positive, I know my parabola opens up. Here we're asked to graph some parabolas. We'll start with this one. Because of the way that it's written, I can see that my h is 0, and so is my k. There is no hk, and my a is -2. That tells me that the vertex is at 0, 0. So the vertex is at the origin, and I know my parabola is going to open down because a is -2. Now what I can do to find some other points is I can just make a table of values and then use some symmetry. Well, I know 0, 0 is this point, so if I try a 1, if I plug a 1 in for x, I'm going to get a -2 for y. So I can put that point there. And because the axis of symmetry goes right through the middle, right on the origin here, I know that there has to be a symmetrical point on the other side. And then I can do even one more. I can put a 2 in for x, get a 4. 4 times -2 is -8. And that points down here. There must also be another symmetrical point on the other side. So with that many points, I should be able to sketch my parabola pretty well. In this example, you see it's in standard form. So I can tell that my h is going to be a 2, because the h is right there, and the k is the number back here, so that's a 3, and my a is -2. So this is going to be the same parabola that I have over here. It's just going to be translated 2 units to the right and 3 units up. So 2, 3 is where my vertex is going to be. I know my axis of symmetry is going to go right through there. And because it's the same point, over here I went to the right one and then down 2, so I know there's going to be a point here and here. And then if I treat this kind of like the origin and I go over 2 down 8, I know there's a point here and here. So what this illustrates for us is it shows us how the h and the k are nothing more than the same parabola. It just translates the vertex over h and up or down k units. Here's another example that I'm asked to graph. One thing I'd like to do is get it into standard form, and because the y is the squared variable, then I know this is going to be a parabola that opens left and right, so it's going to be in this form. So I've got to get my equation to match this so that I can figure out what my h, my k, and my a are. So I'm going to move the y squared over and make this y squared plus 2y plus 13. And now I could divide by 4, but that'll make these all fractions over here. So I'm going to hold off and leave the 4 over here for a little bit. And I'm going to try to set up my perfect square trinomial by grouping the y squared plus 2y. Now to complete the square, I take half of b, which is 1, and square it. So I'm going to add 1 here, which also means I need to subtract 1 on the end of this so that I can actually add a 0. So now that this is a perfect square trinomial, it creates a y plus 1 squared plus 12. And now I can divide this term by 4, this term by 4, and this term by 4, giving me a 1/4 y plus 1 squared plus 3. And that's much nicer than if I would have tried to divide by 3 up here. So here is the standard form for my parabola. So I can see that my h is 3, because the h comes at the end here, if it's in this form. My k is -1, because the k is in here after the minus sign. And my a is 1/4. So now I'm going to list all the different things that we can tell about this parabola. For example, we know the vertex is going to be at 3, -1. We know the axis of symmetry is y equals -1. It's going to be a horizontal axis of symmetry because this is a parabola that opens to the left and right. I'm going to go up here and find the focus. If you go back to the concept summary, you'll see that the focus is h plus 1 over 4a, and k. That's the ordered pair that makes up your focus. So for ours, the h will be 3 plus 1 over 4 times, and my a is 1/4. And my k value I already know is -1. So doing algebra here, 4 times 1/4 is 1, 1 over 1 is 1, and 3 plus 1 is 4. So we now know that my focus point is at 4, -1. Likewise, the directrix is the line x equals h minus 1 over 4a. So that's 3 minus 1 over 4 times 1/4. So that's a 1, 1 over 1 is 1, and 3 minus 1 is 2. So I know my directrix is 2. We know because the a is positive, it's a 1/4, this parabola opens up. And then I'm kind of out of room for it here, but the length of the lattice rectum is 1 over a. And since a is 1/4, it's 1 over 1/4, which is the reciprocal. So the length of the lattice rectum is 4. So all that information can be found by putting my equation in standard form. And now I should be able to graph all that stuff and then show you a graph of what the parabola looks like. So here I try to put everything on the graph here so you can see it. The vertex is 3, -1, that's in blue here. Axis of symmetry, y equals -1, that's in blue. Then I used green for the focus. The focus is this dot right here, it's at 4, -1. The directrix is also in green. It's here at x equals 2. The parabola opens to the right. Initially I said it opened up, but we're talking about a left-right parabola, so it opens to the right. And then in red, I did a length of the lattice rectum is 1 over a, which is 4. So I made this red line 4 units, and that showed me where I had to graph my parabola.